All right, so we're doing chapter 7, lesson 1, equations. Before we begin, what was the one thing you guys learned about last chapter that is related to equations? Remember, there was a difference. This is one of your quiz questions. What did we learn?
The difference between an equation and an expression.
Okay, what's the difference between an expression and an equation? Go.
An expression doesn't have an equal sign. It's just saying that, but an equation has an equal sign and should have an answer.
So we are going to be talking about equations today. The difference between an expression and an equation is an expression does not have an equation. So for example, 5 times x, that's an expression. That could be anything, right? That could literally equal anything because it doesn't tell us what it has to equal. Now, when it becomes an equation, we are pigeonholed into it having to equal something. 15x now equals, 5x now equals 15, which means x has to be what, ladies and gentlemen?
3.
So 5 times 3 is 15. So the equation part basically means that it gives our variable an actual defined value. It has to equal a certain thing. With an expression, our variable could equal whatever. But with an equation, our variable now is given an absolute definition of a value based on what our equation says. There are a few things you guys are going to need to learn on how to solve algebraic equations. The main subject, or anybody know what the main point of algebra is? What is the main point of algebra?
Like figuring out the missing part.
Which, okay, let's use vocab speak. You're right. Figuring out the missing part or the missing value, which is known as our what, ladies and gentlemen? So variable. Remember, our value can vary. We don't know what it equals. So algebra is just figuring out what the variable is. That's it. How did you guys figure this out? Who can raise your hand and tell me how they figured it out? Brody.
If 5 multiplied by something that equals 15, you'd add, or if you wanted to, you could add 5 plus 5 plus 5 however many times if you wanted.
Although we figured it out differently. Okay, so Aldo just kind of gave us the way to actually answer it. So I'm going to walk you guys through this. This is going to be a lot. When you solve algebraic equations, you are basically figuring out what the variable equals. That is our point. In order to figure out what the variable equals, we need to isolate the variable. Now, COVID's been a thing, so everybody here should know what isolate means. What does isolate mean? Okay, so we want that variable by itself. In order to do that, I need to get the variable by itself on one side of the equation, and I need to do certain things in order to do that. So, first thing I'm going to teach you guys is this. When you look at the equal sign, think of it as a mirror. Okay, so you're looking in a mirror. If you raise your arm, does your reflection raise its arm? Ladies and gentlemen?
Yes.
Okay, so whatever happens on one side of the equation has to happen on the other. That's a big takeaway, okay? I want x by itself. I want to isolate it. That's known as isolating the variable. You may want to write that down. Isolating the variable. That means we get the variable by itself on one side of the equal sign. I want that variable by itself. In order to do that, I'm going to have to do or undo the math that is happening to it. Okay? What is happening to x right now in this example? Let's get some different people in here. Pixar, what's up?
It's getting multiplied.
Be specific.
It's getting multiplied by 5.
Okay, so that variable is being multiplied by 5 right now, right? Okay, there's a new vocab term that's not in this lesson, but we're going to front load. To do the opposite of what math is happening, it's called the inverse operation. Inverse operation. So I will type up the two things that I just told you guys. So we want to isolate the variable, and we do that by doing inverse operations. Another way of saying inverse operations is just the opposite of what's happening. So I'll use Brody as an example. If I give Brody $5, what math did I just use? I just added. I added $5 to his wealth, right? And if I want to take those $5 back, what do I do? Subtraction. The opposite of addition is subtraction, right? In this case, our 5 is being, or x is being multiplied by 5, right? What's the opposite of multiplication, everybody? So, in order to isolate the variable, which is our x here, to get it by itself, I need to get rid of all the other math that's happening, or inverse operations. I need to use the opposite in order to get rid of it. So, if this is being multiplied by 5, what do we suggest we do to get rid of it? Everybody? Okay, specific. Divide by 5. We have to divide by the same number. Now, remember, this goes back to the mirror situation. If you lift your hand in the mirror raises its hand too, right?
Yeah.
So if I'm dividing this side by 5, I have to do it to the
Other side.
I have to do the same thing. And this is what Elbow said. Elbow went, well, 5 times something equals 15. The opposite would be 15 divided by 5 to figure out that number, right? Guess what? 15 is being divided by 5. 5 divided by 5 on this side will be 1. We don't say 1x, we just say x. So these cross out. So x will now just equal whatever 15 divided by 5 is, which is what, ladies and gentlemen? So x equals 3. And that's algebra. That's it.
That's our whole lesson.
Basically, in a nutshell, yeah. But we're going to keep going with examples. So the way that this lesson works is they give you baby steps. They're like, okay, if this plus this equals this, can it be this number? Can it be this number? Can it be this number? It's annoying and it's really condescending because you guys know better. So we're not going to do those baby steps today. We're not. I'm going to teach you guys how to actually solve this. So we're going to go straight to one of your homework questions. And this homework question says h plus 9 equals 21. And it gives you these answers. It gives you these options. They want you to plug in 10 plus 9 equal 21. Does 11 plus 9 equal 21? Does 12 plus 9 equal 21? We don't want to do this. We're going to show you how to actually solve this without these options. So h plus 9 equals 21. Remember the vocab I taught you guys. Isolating the variable and inverse operations. Let's identify my variable. What's my variable, ladies and gentlemen? H. That's my unknown value. What is happening to h, ladies and gentlemen? Being added. 9 is being added. So what's the opposite of adding 9? And if I subtract 9 from here, I have to do it. Remember, if it happens on one side, it happens on both sides. When I subtract 9 from here, these will cancel out. H will just equal 21 minus 9. Anybody have any idea what 21 minus 9 is? Hunter. 21 minus 9. You raising your hand? Oh, I didn't hear you. Sorry. It equals 12. And then we plug it back in to see if it works. 12 plus 9 equal 21? Yes. Therefore, h equals 12. And that's literally it. That's it. That's algebra. Now, let's take it one step further. Now I'm going to teach you guys some other tricks. Here's another homework example, and this is question 7. Last period asked about this. Question 7. 9w equals 45. This is kind of like the question we just did with 5x equals 15. 9w equals 45. Okay, what's our variable, everybody?
W.
Okay, what is happening to w, everybody? Okay, thank you for being specific. What can I do to undo this? Or that is known as my what? Okay, so what is the inverse operation of multiplication, everybody? So I'm going to do what?
Divide 45 divided by 9.
Why am I going to just divide 45 by 9?
Because
Hey, Pixar's raising their hand. Pixar's raising their hand.
and 45 divided by w.
Okay. I need to divide both sides by 9. Remember, the mirror effect. Both sides by 9. Because remember, if I divide this by 9, they cancel out. Now w's by itself was what I want to do, right? I want to what? Look at your notes. You guys wrote this down. I want to do what to the variable? Isolate the variable. In kid speak, what does that mean? get it by itself. Question.
So if you put, like, if you don't do that, would you still get it wrong? Like, would it get marked wrong if you already knew what the
I want you guys, remember, you guys have to show your work. You guys have to show your work. So you have to set up. That's why I'm showing you exactly how to do this. You have to show this. I know some of us could look at it and be like, oh, that's 5. Easy. Because you guys know better. But you got to explain how to do it. That's the thing.
So it would get marked wrong if we didn't?
If it's a test or a quiz, yeah. Yeah, I'd have to. So I'm dividing both sides by 9. Those 9s cross out. So W is now by itself. And W will equal whatever 45 divided by 9 is. Remember, I write this as a fraction. Because remember, numerator divided by denominator. What's 45 divided by 9? Everybody should know this. 5. So W equals 5. And that would be your answer. This is literally all your work. This is all the work I expect to see for that question.
And
That's it.
plus it gives you options of what it could be. Correct?
What do you mean?
So if you go back to put like
Oh, on the homework, yeah, it tells you, oh, would this work, would this work, would this work? That's pandering. That's baby level stuff.
is there a possibility to scribble it out?
I could, but it's gonna look at like a mess. Just ignore the options they give you. Just ignore the options they give you. You're gonna do the homework this way. You're gonna show me how to solve it the way that I taught you by isolating the variable and doing inverse operations. Okay, and let's look at the rest of the lesson to cover. Yeah, last period it took a little bit longer because we were learning things, but I mean, we're getting through this pretty quickly. So let's use this as an example. This one's a little bit harder. Anna bought a package of 6 pairs of socks, okay? She writes the equation below to find out how much she paid per pair. Circle the solution of the equation. So they're giving us options. We're going to ignore these options right now. 6 times X equals $9 because X will be the cost per pair of socks, okay? Now this one's a little bit harder. 6 times X equals $9. Knowing what I just taught you, we need to identify the variable first. Everybody, variable is? Then we need to do what with our variable, ladies and gentlemen? Oh, use the vocab. Use the vocab. What do I do to my variable in order to solve it? Everybody. You need to isolate it. I can only isolate it by undoing whatever math is done to it, which is known as, everybody? Inverse operations. So what is happening to the X? So the opposite of that, or the inverse operation of that, would be? Remember, if I divide this side by 6, I have to do it too. Yep.
Which is 9.
Okay. So basically, 1 pair of socks, these will cross out, will equal whatever $9 divided by 6 is. And this is where it's going to get tricky. This is where calculators can come into play. I'm going to use a calculator and not do the long drawn-out method. 9 divided by 6 will equal 1.5. But my answer should not be 1.5, should it?
No, 1.50
Pixar?
would be $1.50.
All right, and I have to tell you guys this. I'm about halfway done grading everybody's tests. Like, I've been grading, like, pages. The dollar sign goes here, ladies and gentlemen. I've literally seen something like this on our test. Not okay. Not okay. Dollar sign goes in the front. That's like, instead of saying Mr. Pastor, you guys write Pastor Mr. I'm not Pastor Mr. That's not how that works. The dollar sign goes in the front. Okay, so 1 pair of socks equals $1.50. Now you guys know how to solve algebraic expressions or equations. Sorry, I said expressions. Equations. I'm going to look through the rest of the lesson, see if there's anything else that needs to be taught that's super, super duper important. All of this is guess and check nonsense and then plugging it back in. Yeah. Okay, G minus 7 equals 3. Now, a lot of us can do this mentally, right? G minus 7 equals 3. What does G need to equal in order to make this true?
4. Or,
Ladies and gentlemen? Ladies and gentlemen? 10. 10 minus 7 would be 3. 4.
no.
Okay, so
4 plus 3.
now in order on a quiz or a test to show me that you know this, this is what it should look like. Inverse operations. What's happening to my variable, ladies and gentlemen? So the opposite would be? Okay, be specific. It's being subtracted by 7. I need to add 7 to both sides. Both sides. Remember, this is a mirror. So I'm adding 7 here. Got to add 7 here. These cancel out because negative 7 plus 7 is 0. G will equal 3 plus 7, which is 10. And that's how you would show me to solve it.
I did none.
Well, I'm just showing you. That's how you would do it.
Yeah, no. Wait. No, I think 7 minus G equals.
Any questions on these? Or are we all good?
Yeah, it is.
Olivia.
Oh wait.
Shh.
When you skipped over on the window, there was usually I put that in my notes.
Oh, these things?
No, that.
What thing? This? You can if you want. This is talking about plugging in a number to see if it works. And that's what we talked about, like once we solve it. So since we solved it here, I'm actually going to plug 10 back in here to see if it works. 10 minus 7 should equal 3. It does. Therefore, I check it off, and that's the correct answer. That's what this is talking about right here. It's plugging in values. 2 plus x equals 9. What plus 2 would equal 9, everybody? 7. So they plugged in 7 to make sure it works. This does not show you to subtract 2 from both sides like I'm teaching you. That's the way I'm teaching you is the advanced method because you guys are going to have to do this eventually. Question?
How come like on the last problem that you did, you didn't say that 7 plus 7 equals 14? Does that not do something?
Negative 7. I'm subtracting 7.
Oh.
A negative plus a positive would cancel out, especially if they're the exact same value. So, like, if I owe him $7 and I give him $7, now there's 0. There's an account. I'm done. So negative 7 plus 7 cancels out. It's the opposite. So, like, when you multiply, when you divide, you undo it, right? If I'm dividing, if this was like G divided by something, I would multiply it to undo it, and then it'd cancel out. So minus 7 plus 7 is 0. They cancel out. So G is by itself now. But I added 7 on this side. 3 plus 7 is 10. That's why that's there.
So if we're doing if we just know that G is 10, can we just write that?
No,
Or
you need to
have
show you got to show your steps. Okay. Now, I'm going to give you guys an advanced question because somebody brought this up. Somebody pick a letter. Any letter.
L.
I heard A.
I said grade.
Sorry. A over 2 equals 18. What does that mean if I put A over 2, ladies and gentlemen? I said, ladies and gentlemen, what does that mean? A over 2 means
It's a fraction.
it's division. That's A divided by 2. Anytime you see something like that, this basically means A divided by 2. Remember, a fraction, we talked about this. A fraction is a division problem that hasn't been solved yet, right? That's why our division symbol looks like this. 2 dots meaning representing numbers that we haven't plugged in. So, A divided by 2 equals 18. How would I solve this? Alex.
The A would be 9.
But you get to show your steps. And A is not going to be 9. I'm going to tell you that right now.
So 2.
Okay, let's take the baby steps that we learned. What's our variable, everybody? What's happening to our variable, everybody?
being divided by 2.
Okay, remember, in order to get a variable by itself, we need to do the opposite of what's happening to it, which is inverse operations. What is the opposite of dividing something by 2?
Multiplying by 2.
So, since my A is being divided by 2, I'm going to multiply it by 2 instead. But remember, if it happens on one side of the mirror, so this will also be multiplied by 2. A divided by 2 times 2 undoes everything. Just cancels out. It's just A by itself. Okay? It's like taking 2 steps forward and then 2 steps back. You're back where you were. So, since A was being divided by 2 and then I multiplied it by 2, cancels out. We all understand that, yes? Just cancels out. So A will now equal whatever 18 times 2 is. What is 18 times 2?
36.
So A will equal 36. And if I plug that back in here, A equals 36. 36 divided by 2, is that 18, ladies and gentlemen?
Yeah.
Therefore, A equals 36. And that's it. So these are baby type of algebraic equations. Eventually, you're going to have a bunch of different things happening and then variables on like both sides, which changes the game. So I don't know if I have the example from last period. Let's see if I do. I do. Boom. I'm going to erase all of this and show you guys exactly how to do this. So this was an algebraic equation that I had made up. 2x minus 3 plus 5 equals 27 plus x. What do we notice about this algebraic equation right off the bat? It's the first thing you notice.
It has 2 variables.
Yep. And the variables are on, ladies and gentlemen? Opposite sides. When I want to isolate the variable, I have to get the variable on one side by itself. So I will be subtracting a variable eventually. What else do we notice? There's multiple steps here, right? So this is why we learned last chapter about combining like terms, right? If I had, say on this side, I had like multiple x's, I'd combine those x's into one. Here, I have multiple whole numbers. So I can combine these two right off the bat. So I would rewrite this. This would be 2x, and what's negative 3 plus 5? Everybody? Anybody have any idea? Negative 3 plus 5 would be? 2. So I'm going to do plus 2 equals 27 plus x. Okay. Only focusing on this side. This is the side we want the variable by itself. What's happening to my variable now? Now there's two things happening to my variable. What is happening to my variable? And it's being
Multiplied by 2.
we need to get rid of one of them first. I'm going to wait for the multiplication first. I'm going to get rid of that one later. I'm going to get rid of that plus 2 right now. So what's the opposite of plus 2, everybody? So I'm going to subtract this 2, and I have to do it from both sides. So this will be 2x equals, what's 27 minus 2? Everybody? This will just be 25 plus x, because I can't take away the 2 from the x. But now I have 2x equals 25 plus x. I need that x away. I need that x on one side. So I'm going to subtract an x from this side, subtract an x from this side. That will then turn this into x equals 25, and that's it. And if I plug this back in, I'm going to show you how this works. I'm going to erase all of this work, and x will equal 25, and it should work. What's 27 plus 25 on this side?
52.
Okay, so this side is 52, which means all of this should equal 52. What's 2 times 25?
50.
Minus 3 would equal what?
47.
Plus 5 would equal what?
52.
So 52 equals 52. Therefore, x is 25. That is a harder level question that we're not working on right now. It's just an example. But you guys all know how to solve algebra now. And that's it. That's all it is.
That's all the lesson.
That's the whole lesson. And that's probably going to be the next lesson too, to be honest. Let's see. Next, solve and write addition equations. Yep, there we go. Inverse operations, and then the subtraction property of equality, which we'll talk about next lesson. But that's it. That's how you solve algebraic equations.
Was this multiplication?
You guys realize it's still recording though, right? So,
Was this the multiplication?
yeah, it's still recording. So what?
Was this the multiplication property of equality, or was it?
No, this is just the intro. So each lesson's going to talk about division, or yeah,
there's a lot of
because this was what? This is solving and writing addition equations. Lesson 3 should be subtraction equations. Yep. Lesson 4 will be multiplication equations, which means lesson 5 is going to be division equations. So Yeah.
And then we're done with like all math.
No, we're gonna do a third chapter. We're gonna get a third chapter in. So your homework for tonight / tomorrow's class period / possibly Wednesday if we see each other on Wednesday is every question 1 through 23. Any questions before I stop the recording? Yeah, this is going. I told you guys this is going onto the Math with Mr. P page.
Did you record last period too?
No. All right. Well, that's the end of this video. I'm not doing the outro and leave a comment, whatever.
Do it.
Okay, wait. Pixar wants to do it. Go.
Wait. What do I say?
I don't know. You said you want to do it. So go. So who wants to do it? Okay, well, it's recording right now, so you guys gotta do it quick. Shh, they're doing the outro. Shh, go.
What do we say?
I don't know. You guys watch my videos. What do I always say at the end?
It's
If you have any questions in the classroom,
Yeah,
please let me
any
know. And
questions,
this was
comments, or
Mr. P.
concerns? See you guys in the next one. This is Math with
Mr. P.
All right. Well, we'll end it there.
That was close enough.